Welcome to lesson 8.2. We are going to start this lesson off by making a very important distinction. And that distinction is between actual area and signed area. Now, so far we've been doing a lot of signed area, aka integrals. Signed area is integrals. And that means if the area is above the axis, it's positive, below the axis, it's negative. However, that is very different than if a problem asks you to find area. When a problem says area in the instructions, that area cannot be negative. So if you find integral, that signed area can be positive, negative. If it says area in the problem, it has to be positive. Now let's talk about a new idea. So far at this point, we've been doing curves like this, and then having things like maybe this, and we wanted to find the area under the curve from one point to another. That's the kind of stuff we've been doing so far. So the area for these were always from one curve to the axis. But now we want to change it. We want to say, well, what if I want my area to be from one curve to another curve instead of to the axis? So now we've got this area. That's the kind of stuff we're talking about right here. Now there's two different ways you could do this. The most common one is right here. And it's, you take your top curve and you subtract your bottom curve, and that will find the area between them. Pretty self-explanatory for that. However, we're also going to do a new one for functions of y. So if your equation is in terms of y instead of in terms of x. We've been in terms of x pretty much all year long. But now we're saying maybe instead we're in terms of y. If you do something in terms of y, then you would do the right curve minus the left curve. That one is not as common as this top one, but it does happen. So, let's start with example number 1. We want to find the area of the region bounded by this curve up here, y equals x squared plus 2. This linear down here, y equals x. And then I have x equals 0, this line, and x equals 1, this line. And I want to find the area of this space. So we're going to do our integral. This one's going to be in terms of x because we're going to do top curve minus bottom curve. Top minus bottom. So we're going to do our integral from x equals 0 to x equals 1. Make sure our limits are in terms of x because that's what we're going to do, top minus bottom. And then we want to do the top curve minus the bottom curve, dx. So let's plug this in. The top one is x squared plus 2 minus the bottom one is x. So I'm going to rewrite this, x squared minus x plus 2. And now, this is a problem like we've been doing before. So let's take the integral, x cubed over 3 minus x squared over 2 plus 2x from 0 to 1. Let's plug this in, 1 cubed over 3 minus 1 squared over 2 plus 2 times 1 minus the 0 version of all that. And when you simplify all of that, you would get 11/6. Now, if it was free response, you could totally leave it at that point and be fine. With multiple choice, you'd want to simplify it. So that is saying this area between these two curves is going to be 11/6 square units. That's how big that area is. So in the next video, we're going to try an example that would be in terms of y, and talk about how being in terms of y can be different than being in terms of x, which is what we just did.